Okay, so you don't need my mug up here anymore. So it says the armature of a simple AC generator has 50 circular loops of wire. Okay, so we know N is equal to 50. So we'll write that down. N is equal to 50. Next step. Each wire with the radius R is equal to 0.2. That's a piece of cake. Oh, wait. What did I say? Radius of 0.5. Diameter is 0.2. So the radius is 0.1 meter. All right. So tracking along, and it's rotated with a frequency of 60 hertz. So F is equal to, so I wrote here, F frequency is equal to 60 hertz. You seasick yet? I would be. And in a magnetic field of 700 milliteslas, which is 0.7 teslas, we'll go with 0.0. We'll go with 0.700 teslas. Okay? There we go. So the teslas is equal to 0.700. We'll take this out to 3 sig figs. That's the magnetic field in teslas. All right. So let's answer their question. So let's just get the equation started that we know. All right. I do know this. I know that omega naught is equal to BA times 2 pi times the frequency. Okay. That's equal to omega naught. And then omega is equal, or the EMF at any juncture is equal to this maximum times the sine of 2 pi times t. Oh, times omega times t. Well, I don't know I know that omega is 2f times t. So in other words, we get, I'm sorry, I kind of ran into a little hiccup there. Sine of 2 pi times the frequency times t. Notice what happens. Notice if I take the frequency, which is in hertz, this is seconds to the minus 1. Seconds to the minus 1 times seconds, the times actually cancel, and I wind up with an angle that's a factor of the frequency times the time. Okay? And so we got to look at things, and this thing moves along. Since it's a sine curve, we're going to assume if it says it starts at a maximum, then it's going to start up here. This will be E naught, and this will be negative E naught down here. Now, when does it hit negative E naught? At what juncture? What juncture does it hit? Or first of all, when does it hit 0? What is the angle when it hits 0? If this is at 0 and this is 180, well, this is pi, and then and then this is pi, and then it comes back up here, gets back to 0 again, then it comes up back to here to E naught again, and this is 2 pi. Then what are these, since it's a nice sine curve, what is it? Right, this is at pi over 2, and this is at 3 pi over 2. I was getting ready to say something stupid like 3 pi over 4. Okay, so those are the points. In other words, I've got to make this inside equal either 0. Well, when this is pi over, when this time here, when the time is equal to pi over 2, then that's when it works. All right. That made no sense, what I just said. So I'm going to stop right now, and then we'll get more into the problem.